Save big this summer with great deals, all in the Baker's app. Get red, green, or black juicy seedless grapes for $1.88 per pound with a digital coupon. Then buy 2, get 2 free delicious 12-packs of Coca-Cola, Pepsi, or 7-Up, all with your card. Shop these deals at your local Baker's, less than 10 miles away. Or tap the screen now to download the Baker's app to save big today. Baker's, fresh for everyone. Prices and product availability subject to change. Restrictions apply. See site for details.
Fairly often, I get asked questions about how I got started podcasting with the Breaking Math podcast, and I'll often be asked this question by those who are thinking of starting their own podcast. That is, people who are looking to tell a story or share their unique wisdom with a larger audience or their passions, or maybe just advertise their business or services. I usually like to start this conversation by either showing off or telling about our preferred podcasting platform, Zencastr. Zencastr is essentially an all-in-one podcast hosting platform. On this platform, you can do everything from recording your episodes to editing your audio and video files to distributing your podcast to all podcasting platforms, including Apple Podcasts, Spotify, iHeartRadio, and wherever else podcasts are played. Now, there's more. When I first began podcasting, I used to get very nervous about how I would sound. I would sometimes stutter or have awkward pauses or other audio blemishes in my recordings. Now, Zencastr has a new suite of AI tools in their post-production process that make you sound really smooth. They automatically take out any of the ums or ahs in your recording. Also, they automatically take out any of the awkward pauses in your discussions. The tools will also help you set the right loudness and balance all the levels while reducing any background noise, all with the click of a button. Doesn't sound too bad, does it? You really should check it out. Really, the world needs to hear what you have to say. In fact, I'm going to give you a code below to help give you a large discount. It's all one word, Breaking Math. Go to zencastr.com/pricing and use my code BreakingMath, and you'll get 30% off of your first month in any Zencastr paid plan. I want you to have the same easy experience I do for all my podcasting content needs. It's time to share your...
Seldom do we think about self-reference, but it is a huge part of the world we live in. Every time that we say myself, for instance, we are engaging in self-reference. Long ago, the liar paradox and the golden ratio were among the first formal examples of self-reference. Freedom to refer to the self has given us fruitful results in mathematics and technology. Recursion, for example, is used in algorithms such as PageRank, which is one of the primary algorithms in Google's search engine. Elements of self-reference can also be found in fundamental shifts in the way we understand mathematics, and has propelled our understanding of mathematics forward. Forming modern set theory was only possible due to a paradox called Russel's paradox, for example. Even humor uses self-reference. Realizing this, can we find harmony in self-reference? Even in a podcast intro, are there elements of self-reference? Nobody knows, but I'd check if I were you. Catch all of this and more on this episode of Breaking Math. Episode 70.1 of Breaking Math Podcast.
I'm Sophia.
And I'm Gabriel.
And you're listening to Breaking Math Podcast. With us, and who did the intro, we have on Millie of Nerd Forensics Podcast, another podcast in Santa Fe Trail Media. Welcome, Millie.
I'm back, everybody.
I am thrilled to have you, Millie. Nerd Forensics has been an absolute blast to listen to. Yes, I'm totally plugging it, but it has been. It's like a chance to let our hair down and just talk about the nerdy stuff, like Star Wars or The Simpsons or whatever. So, yeah, glad to have you here.
I'm glad to be back. I'm actually planning on recording a few episodes this week. So
I know it has been a little while. Your intro was all, if you don't mind, I'm going to dive right in here. Your intro was all about self-reference. Now, I want to mention one thing. We trolled you all of you all who are listening to this, yes, we trolled you a little bit. You may have noticed on your podcast player that there was episode 70 with a certain title. What was it called, Sophia?
This episode intentionally left blank.
And it was literally like 45 minutes of nothing but white noise. Now, there's a reason why we did this. It's a little risky. Sometimes when you're trying to be funny or humorous or original, you have to take some risks, and we just did that. I don't know if we lost listeners or not, but we don't really care. Well, we do, but there's a reason for it.
I dare you to delete us from your podcast player. Do it.
Yeah. No. Yeah. We hope you don't, but do as you wish. I remember as a young kid, I'd always open up a book in a library, and the first page you'd have, the publisher. Then you'd have a page that actually says this page intentionally left blank.
I've seen that a lot in testing packets.
Yeah. And I always thought it was funny. Like, well, why did you do that? As a kid, I was so worried about recycling and wasting paper. You're wasting paper. Anyways, when I met Sophia, we had Post-it notes everywhere, especially when we were planning this actual podcast. We had all kinds of Post-it notes one time, and I saw that Sophia had written one Post-it note with some notes on it. Then right next to it, she put this Post-it note intentionally left blank.
Oh yeah, wasn't that when we were doing the project,
My
the genetic algorithms one?
Yeah. I thought it was hilarious because it reminded me of those books that I read in school. So anyways, in an episode that's all about self-reference, we did that. Now, I want to mention that I took your humor, Sophia, and I had my stepdaughters do that with their dad because they always, we're good friends with their dad. We always talk about dad jokes and inside jokes, so they always write each other Post-it notes. So I'll have you know they stole that joke. I also stole it at work. We've got these whiteboards that are cubicles that we were all given. The whiteboards are supposed to have important notes as well as where we can be found if we're not at our desk. So I did two things. I wrote on one part of the whiteboard, I wrote, this section of the whiteboard intentionally left blank. Then beneath that, I wrote, if Gabe is in the chair, he's here. If Gabe is not in the chair, he's not here.
Oh yeah, tautology, right? So that also brings up the point, what is self-reference? And it's a difficult question because it's kind of nebulous. It's something is self-referential. I would say it's self-referential if there's an element that can be said to be part of the thing that either encodes the thing or points to the thing.
Is that the technical definition you'd find? The thing,
Oh yeah, read the philosophy wiki on the word thing. It's like 10, 20 pages long.
That should be punishment. You know what I mean? Like, we should actually have somebody do that as like a dare. Anyways, you're right. Self-reference. When I was thinking about it myself, I tried to think about how to explain self-reference. And I think the way I described it is like, I'll use the word thing liberally as well. You'll have to forgive me. Whenever you have a thing, like, say you're going to design a little artificial intelligence robot or something, it has to map its environment around it. It has to take input data on the world around it and makes a little internal map. Whenever you can have something like that eventually can map itself, it refers to itself.
Yeah, because you have the location of where it is. Like, maps themselves are sort of a self-referential meta sort of thing. And anyone who's under 40 knows the expression and is sick of it by now, pull yourself up by your bootstraps, which is pretty self-referential.
Yes.
If you think about it, you pull yourself up by your bootstraps, you can't do that.
Yeah.
You'd fall on your head.
Oh, no, exactly. And Millie, can you think of some examples of self-reference you run into?
My favorite example is "You are here" with a big star in the middle.
Oh yeah, and like malls.
Yeah.
Yeah. What is that thing in The Simpsons when they go to Area 51A?
Yeah, it's "You are here, we are not."
Oh yeah.
That's hilarious.
And before we dive into this episode, we're gonna talk a little bit about. We're gonna have a few guests on for a joint episode in either next or the one after that episode, I think.
Yeah. So what we can tell you is this: we are planning to do it very, very soon, perhaps as soon as a week, but the details are still being finalized, so it's still maybe a ways out. However, the Breaking Math podcast is going to team up with another fabulous podcast, a hardcore science and engineering podcast called the Materialism Podcast. Now, this is put on originally by an Andrew Falkowski and Taylor Sparks. They are also joined by a Jared Duffy, who's a mechanical engineering student, and Ramsey, I believe, Issa, a materials science PhD student. Quick note here. This is Gabe, of course. I was very excited when I found a materials science podcast because I was almost a materials scientist myself. I'm obsessed with materials science, and I get very excited by all of the stuff that we haven't discovered yet. You can get into sci-fi about what material properties, like what have we not harnessed yet in terms of technology.
Oh yeah, I remember when you were doing that antenna design class, right? There's those weird problems about like spheres of like weird jelly that refracted in one way and didn't in another way with the electronic waves.
Yeah, so I want to encourage our listeners to check out the Materialism podcast. What I've also done for my co-host Sophia. And I'm so sorry, I forgot to mention we're going to be joined by a friend of ours, the mad scientist Scientist podcast host Chris Cogswell, Dr. Chris Cogswell, who has his PhD in chemical engineering.
His podcast is pretty awesome. It's kind of diving into a lot of like pseudoscience in a mathematical and very scientific way.
Yes. So we will have the Breaking Math podcast, who have got folks who are into mathematics and computer science and electrical engineering. We will have a chemical engineering podcast or host, and we will also have material scientists. And it'll be focused on material science as well as their show.
And of course, our episode is the superior because everyone uses math. No,
I love those fights. That kind of infighting is always all kinds of fun. But listen, before we move on to the next section, I recommend our listeners check out their site and look at their show notes. They have episodes on things like an interview with a company that's making biodegradable packaging, for example. They have all kinds of episodes on what kind of materials can you use in science and medicine that your body won't reject and why. And like, how are these materials made? It's fascinating. I also have economics questions for them, like what kind of things in material science like affect economics by making things cheaper, you know?
Oh yeah, either cheaper or there's even the issue of like how dollar bills and stuff are made with those little almost microscopic red threads.
Yeah.
But yeah, we'll discuss all of that on that podcast.
Yeah. So in the meantime, to prepare, just check out the Materialism podcast. You can just Google it and you should find it.
And now, humor and self-reference. One author, and his name is Randall Munro, and he uses self-reference constantly in his comics. And we're just going to do a couple of these.
Yeah.
Just xkcd.com/33 is just 3 panels. And the first one is just somebody saying, I promise to never again squeeze humor out of self-reference. It says nothing in the second panel. Third panel, he says, damn it.
Yeah, obviously it's referring to itself, so you get the humor. I think my favorite one we're going to save for last, but yeah, that's a good example.
Then we got xkcd.com/688, which contains a pie chart, a bar chart, and a kind of like a plot. And the pie chart says how much of the image is red. I mean, how much image is white, how much is black. The bar chart says how much ink is in each thing, how much ink is in the pie chart, bar chart, and the miniature. And the miniature of the comic just kind of is a picture of the miniature of the comic next to a few axes. And what's cool about that is that every single square depends on every other square, right? So like the pie, if the bar chart shows an increased thing, there's more ink in that, so the pie chart's going to change, which means the bar chart's going to change. You know.
Okay, that's totally hilarious. I mean, make a pie chart and just make some arbitrary slice and say this amount of the pie chart is black, this amount of the pie chart is white. Like that's.
Oh yeah, and it'll probably converge. You know.
You know what that reminds me of? That reminds me of Claude Shannon's what is it? The greatest. Oh, what's the name of his machine where you turn it on and all it does is a hand comes out of a.
The useless machine, or.
But it's not. No, it's called like the ultimate machine. I think. Let's find out.
Like the greatest machine ever or whatever it is.
Yeah. Claude Shannon, greatest machine or ultimate machine, I think. Yes, that's what it's called. Okay, yeah. Claude Shannon's ultimate machine. All you do is you turn it on and a hand comes out of some compartment and turns it off. That's all it does.
And then we got xkcd.com/917.
xkcd917 is my absolute favorite. It is divinely funny, and I chose that words intentionally. Let me go to that comic real quick, and I'll explain why. So, it's a 3-panel comic, and in the first one, it has 2 people talking. One of them is at a laptop. One of them is standing beside the person just talking to him, and he says, "What's this?" The person at the laptop says, "Douglas Hofstadter's 6-word autobiography. After all those 700-page tomes, I guess he wanted to try for brevity." And then the other person says, let's see. Then he reads it, and it says, "I'm so meta, even this acronym." And that's it. That's all 6 words. Then he says, "Whoa, I think he nailed it."
And what are the first letters of all those words?
Okay, I'll read that one more time. The first letters of every word in the sentence, "I'm so meta, even this acronym."
ISMETA. So is meta.
Is meta.
So I'm so meta, even this acronym is meta. Which if you've read Douglas Hofstadter, who wrote Godel Escher Bach, I think episode 17 or something was that?
Yeah. I think you're right. We'll have to see it. Or whether it's called Incomplete.
Oh yeah, Incomplete.
It's funny. Yeah. So obviously it's hilarious because meta is that would you say the definition of meta is self-referential?
Oh yeah, meta is almost just a word that makes things self-referential. So like, meta store would be a store that you buy stores in.
Okay. I love that. Yeah, that's great.
What about a store where you buy the currency to buy stores?
Let's see. What would that be? Meta. Okay, so
just self-reference with extra steps.
Oh yeah, but I think we could do this one. Let's see. So you go to the store. You're saying the word for the money that you use to buy stores from the store, right?
A store that you buy money to buy the stores.
Okay, store that you buy money to buy the stores.
I'm thinking of conversions, like when you change one currency to another.
Yeah, like imagine that the store owners only accepted Dogecoin or something stupid.
So
Okay.
I think you call that word meta.
Meta store?
Well, like you'd be like meta cash meta store. You know what? We're gonna work on that, and we'll talk about that next
Can't
episode.
we do like a creative self-referential challenge? Like, say, who thinks of the best plots that are self-referential? I don't know.
I say that anybody who gives us a concise way to define what Millie's. So I'm gonna bring up another XKCD. Let me look it up.
Okay, very good.
So XKCD. So it goes, you're looking festive, and this person with a Christmas hat says, I love Christmas. Really? Doesn't seem like your kind of thing. It's our most meta holiday. How so? All of our Christmas stories now are about discovering the true meaning of Christmas. Huh, yeah. And then sharing it with others. At some point, that quest itself became the true meaning. Like a word whose definition is the act of looking up the definition of this word. Automata logolex? My least favorite of Santa's reindeer.
Okay.
I blame Kirk Cameron.
Another automata logo Lex, I think, is... God, what would another one be? 4th of July? I don't know.
Okay, I'm not going to lie. I think that became my favorite one now. Like, literally. That's hilarious.
Oh, yeah. Automata logo
Finding the
Lex.
true meaning of Christmas itself became the true meaning of Christmas. The quest to find the meaning of life became the meaning of life.
I know the meaning of Christmas. It's Kirk Cameron and Kevin Sorbo need to make a movie together that tells everybody about how they're wrong for writing happy holidays on things.
Hey, let's make a parody on that. I love that plot. Okay, we've veered far off math.
Metastor numisma... I'll figure that out.
Okay.
Sorry, I broke her.
No, it's okay. Yeah.
Now I'm not going to be satisfied until it's like an itch in my brain now. And we have the book Cat's Cradle by Kurt Vonnegut, in which there's a form of ice that they call Ice 9, which is different than the real Ice 9, which was discovered later. It's just a type of pressurized ice that has different properties than normal ice. That's produced from Ice 3 quickly, so it doesn't produce Ice 2. But anyway, Ice 9 in this book, in contact with normal water, produces Ice 9, which is a solid. So basically what it does is some Ice 9 gets out of the laboratory, and it basically turns all the all the water on Earth solid.
Interesting. Wow. Like a Borg type thing?
Yeah, kind of like the bar, but imagine it's just chemicals. Like imagine you just have a form of water that's even more stable than water.
Okay.
That when it touches water, basically it crystallizes outwards.
Okay.
And at the time, this was thought to be there are substances that this does work with, that have this property. So Catch-22. So y'all have heard the expression Catch-22, right?
Oh yeah, absolutely. Yes. That means like almost like you're doomed if you do, doomed if you don't.
Yeah, like you need the thing to have the thing.
Okay.
So the reason why Catch-22 is a book by Joseph Heller. It was published in 1961, and he wrote it in 1953. But in the book, if a pilot is deemed insane, they don't have to fly. To be deemed insane, a pilot must request to be evaluated. If a pilot requests to be evaluated, this demonstrates that he must be sane. Therefore, no pilot can ever be deemed insane, and no pilot can get out of flying.
Okay, makes sense.
And the whole book is about the ridiculousness of the military.
Yeah, it takes place in the North African theater, right?
I've only read the first 5 chapters. I don't quite remember.
It's World War II, though, right?
Oh yeah, it's World War II.
Yeah, I want to say it was the North African theater because I want to say
North
that
Africa
was
or Italy.
Yeah, I was gonna say because I know the whole Mediterranean had like the craziest death rate for pilots in the United States.
Wow, interesting.
Yeah.
And Millie, can you think of any pop culture references that are self-referential?
The entirety of The Dark Tower. That's pretty self-referential to every other Stephen King story.
Do you want to explain that?
Okay, so The Dark Tower takes place in a world called Midworld. that serves as the nexus between all of Stephen King's different stories. Because some stories take place in the same world, others take place in different worlds. A good example is, what is it? The Silver Bullet and It and a few other, like, pretty much any story about, like, a kid who's dealing with something awful all pretty much takes place in the same world as Stephen King.
I see.
And then you have some stuff that, of course, takes place in, like, the real world and stuff. And then Midworld, it's where it all links up.
Oh, okay, so everything's tied together through Midworld. And didn't you say that what was he, Dusty Sam or whatever, the evil guy? He appears in.
Randall Flagg. Flagg, I like Dusty Sam. That's a good name. I'm going to use that for a villain now, Dusty Sam. But Randall Flagg, though, he's in Children of the Corn. It's very likely that he was He Who Walks Between the Rows. He's also the main antagonist in The Stand. And a ton of other stories, Eyes of the Dragon, and a bunch of other stories.
Yeah, and that's kind of self-referential because, you have all these different characters in all these books connected, and then you have the thing that connects them all. So it's almost it's like a self-referential because each world refers to itself, right?
Mm-hmm. And they actually do it multiple times. Flagg, though, is a great example of self-reference because it's constantly referencing him.
So another major thing that self-reference does is it allows for some paradoxes that have shattered all mathematics and logic. So we'll go ahead and discuss a few of those in this section.
Well, and one of the earliest ones, it comes from Greek times, is the liar paradox. And Gabriel, do you want to read the liar paradox?
Oh, totally. Yeah. So essentially, these are two statements, and one of them says the next statement is false, and then the next one says the previous statement is true.
Yeah, and so Millie, which one of these statements is true and which one is false?
Well, neither of them, actually.
Yeah, exactly. Yeah, then that's a paradox, right? Because if the next sentence is false is true, then that means that the previous sentence is true, which means that the next sentence is false is true.
You could make like a logical engine with that, a perpetual motion engine, just by running that.
Oh, yeah, so if the next sentence is false, the previous sentence is true is false, which means that the previous sentence is actually true, which means that the next sentence is false, and it just keeps going around in a circle, right?
Do you remember SpongeBob when he has his arms all tied around himself?
But why would? Didn't he? Wasn't he trying to figure something out?
Opposite day.
Oh yeah, on opposite day. Yeah, it feels like that. Yeah, and the original liar paradox, by the way, it wasn't two sentences; it was just one. It says, "I am lying."
Oh wow!
And it's like, okay, is that person telling the truth? Yes, then they're not lying. Then they are. Then they're not. Then they are.
Yeah, I think it's a little easier, a little more. The paradox is a little more apparent in the two-sentence version.
Oh yeah, and now we have Quine's paradox.
So Quine's paradox, to me, just from looking at it, it looks almost the exact same as the two-sentence version of the liar paradox, except it uses different punctuation.
Okay, so Quine's paradox yields falsehood when preceded by its quotation, yields falsehood when preceded by its quotation.
The first part was in quotations.
Yeah, so yields falsehood when preceded by its quotation, yields falsehood when preceded by its quotation. Now, like you said, it's basically the same paradox as before, right? Is that apparent, Millie? Mm-hmm. And so if you think about it, if the sentence yields falsehood when preceded by its quotation, if you take that and you precede it by its quotation, it yields this sentence, which is paradoxical. Because if it's true, then it's false, and it's true, etc.
Okay.
And the thing that's really good about Quine's paradox is that it doesn't say this sentence, or like it doesn't refer to anything else. It doesn't say this or that or me. It refers to itself indirectly, which is used in a lot of math. Like, for example, in Gödel's incompleteness theorem, that's kind of the way that the Gödel sentence works, is it refers to itself indirectly.
Can't we name 2 consecutive episodes that? The next episode is false, the previous episode is true.
Sure.
One more thing. Hey, quick little humor thing here. Another way of using self-reference as humor. Years ago, when our podcast first began, we were invited to something called the New Mexico Podscape by a local podcast group called City on the Edge, and they were asking us, personal questions as one does during an interview. And Sophia said, "Oh, and be sure to check out our other podcast, Through the Looking Glass, in which we talk about what will be on the next week's episode."
Oh yeah.
Like that's what the podcast is. That's you just discuss what will be on the next week's episode. Like if it's
Oh yeah, each episode is only about what's on the next episode. Yeah.
yeah, like that's the only. So what is it then? It's a self-referential thing. It's hilarious. I loved it.
All right. Yeah, and exactly. And we're gonna get to the last paradox, which actually caused a huge shift in mathematical thinking. So Bertrand Russell was a logician in the early 20th century, and he was studying, or actually it was 1800s, I think. Well, let me check. Bertrand Russell.
Yeah.
Oh, yeah, Bertrand Russell. Yeah, he was born in 1872, so he was about the same time as Einstein and all of them. So just a reminder, a set is just an abstract mathematical concept that can contain anything that you're talking about. So you can say the set of all real numbers, and every real number will be in that. Or you can say the set of Barney and Homer, and the set will just be Barney and Homer. And so you can say Barney is in the set is true, Homer is in the set is true, but Marge is in the set would be false. And for the set of all real numbers, like I, the imaginary number, does not exist within the set, but like 3.97 does.
Yeah.
And he was studying the set of all sets. And I'm re-recording this part because I made a major mistake in the way I explained Russell's paradox. So Bertrand Russell, what he was studying was the set of...
Save big this summer with great deals, all in the Baker's app. Get red, green, or black juicy seedless grapes for $1.88 per pound with a digital coupon. Then buy 2, get 2 free delicious 12 packs of Coca-Cola, Pepsi, or 7-Up, all with your card. Shop these deals at your local Baker's, less than 10 miles away. Or tap the screen now to download the Baker's app to save big today. Baker's, fresh for everyone. Prices and product availability subject to change. Restrictions apply. See site for details.
all sets that have certain properties. So for example, the set of all sets that are even would have 0, 2, 4, 8, 16, whatever, all the even numbers in it. So what he was studying is not just the set of all sets, but the set of all sets that do not contain themselves. So for example, in this hypothetical set, 1, 2, 3, the set that contains just 1, 2, and 3 would be in this set because 1, 2, 3 does not contain itself. However, like a set that did contain itself, which you can actually have when you have infinite sized sets, would not be in this set. And Russell asked a very simple question of the set. Does this set contain itself? That is to say, does a set of all sets that don't contain themselves contain itself? So if the set did contain itself, then it would not be it would not be in the set because of the definition, therefore it would not contain itself. But if it didn't contain itself, then it would have to be in the set, which means it would contain itself. And this showed that you cannot have the set of all sets that do not contain themselves as a set. What this meant at the time was that set theory had to be reformulated. There's certain formulations like ZFC which avoid this, but basically what this is kind of like a litmus test. Any theory that allows the set of all sets that do not contain themselves is an inconsistent set theory, because you could derive anything, true or false, within this system. And we remember from Gödel's incompleteness theorem, which we discussed on that episode entitled Incomplete, any theory has to be either inconsistent, which means that it's basically useless because you could derive anything within it, or incomplete. There are things expressible that are true within the theory that are not provable within the theory. And now, back to the episode. Now we're going to talk about quines. And quines are related to Quine's paradox, that yields falsehood when preceded by its quotation, yields falsehood when preceded by its quotation, in kind of an indirect way. A quine is a computer program that can write its own code. So if you run the program, it'll write something out. And if you compile that, that is to say you run that in the program's code, you'll get that code again ad infinitum.
Yeah, very cool.
Which is kind of strange because you could do it it's proved that you could do this in literally any programming language.
This reminds me of the philosopher question about the original unmoved mover. You know what I mean?
Can you go into that real quick?
Sure. Oh, yeah. This is a very common one right now. This is done a lot in theological debates involving something called the Kalam cosmological argument, I believe. But also it goes back to, I want to say, Plato, if I'm not mistaken.
I think it's actually...
is it Aristotle?
No, I think it's Thomas Aquinas.
Okay, but even before that, no, I think it's Plato. Let's find out. Let's Google search it. But the idea is that whenever something, everything has a cause.
You're right. Aristotle,
okay.
actually, weirdly.
Yeah, so the idea is that everything has a cause, obviously. You know what I mean? Like sun goes onto a plant, and the plant gets energy from the sun, and therefore it produces fruit. Well, these are causal chains. The idea behind an unmoved mover is what caused everything. And it had to be something that itself didn't have a cause. And this example of a code where if you run the code, it will write its own code in sort of a self-referential thing. Well, you had to have somebody run the code in the beginning to start. Now, you can also get further philosophical, like we would be the uncoded coder, but we ourselves have causes as well. So I'll leave the philosophy to our listeners.
Oh, yeah. And Thomas Aquinas actually did use that concept quite a bit in his proto-calculus kind of stuff.
Interesting, yeah.
But yeah, so Millie, is the concept of a quine, what do you call it, clear?
For the most part, you're talking about like something that could like program itself essentially, and
well, pretty much, yeah. But in the only program that it could do though is the program that spits out its code. So it's like it's a lot like the impossible machine or the useless machine.
The useless, it's kind of or the ultimate machine.
Wait,
yeah.
Does quine come from Aquinas?
No.
Are you sure?
I'm positive.
Oh, okay. Well, it's cool. I mean,
yeah, I was actually pretty shocked when he said no.
Because his name is literally Quine is.
Yeah.
Meta.
Yeah.
And I mean, everybody should name everything after themselves. I know Robert Fripp has been fighting for that for years.
Fripp? What's a Fripp?
So looping, also known as Fripptonics.
Yeah.
The guy who invented it, Robert Fripp, he's been trying to get it named after him for years. And it's like musicians are like, no, we're just going to keep calling it looping.
Oh.
So yeah, you can actually talk about a multi-quine in terms of just getting back to this. Parthenogenic lizards, for example, are kind of like a quine. Because parthenogenesis is when something is born, basically a virgin birth, birth without insemination. And so these lizards will produce themselves. And that could actually be done if there were no DNA degradation, it could do that forever, right?
Yeah.
So that's kind of like a quine. The quine just produces itself, which produces itself, which produces itself. And in this case, the birthing process would be like compiling. The DNA would be like the code.
Yeah. Okay, that makes sense. Now, this next section is probably my favorite section of this entire podcast. I'm just going to give you guys a little preview here. So Sophia wrote a little science fiction concept in order to illustrate exactly what we're talking about.
Oh, yeah, the multi-quine. And right before we go into the science fiction, I'll just give the kind of technical definition.
Sure.
A multi-quine is a program that can produce code in a chosen language given an input.
Yes.
That produces the multi-quine in whatever language that you choose. So, like for example, a multi-quine written in C could produce the same multi-quine written in Java or C given the input Java or C. Yeah. But that's kind of confusing, right?
Well, sort of. I mean, so, okay, yeah. For the sake of this episode, I'll say, yes, it's confusing. An illustration would help. And for all of our Breaking Math listeners who are into science fiction or creative writing, check this out. This might be a good writing prompt for you.
Suppose we were on the planet Xannet. There are 5 species of different planetary origins here. There are the Greys from Alpha Centauri. There are the Blues from Beta Malari. The Pinks from Floridia. Humans from Earth. And the Shadow People from Planet X. Just as humans have DNA to represent their genetic code, the Greys have ANA, the Blues have BNA, the Pinks have CNA, and the Shadow People have ENA. As part of a futuristic pact, they produced multi-quine specimen Dolores together, a human who is the first of a multi-quine people. Dolores' DNA has been altered so that she can produce ANA, BNA, CNA, DNA, or ENA out of her earwax based on brain waves. If Dolores closes her eyes and goes into a trance and pictures either a gray, a blue, a pink, a human, or a shadow person, her ears will produce the genetic code to produce another multi-quine specimen. For example, if she thinks about a gray during a trance, then ANA will be produced out of her ear. And if the ANA is taken and it's put into a gray's egg, it will produce another multi-quine specimen, say Dolorix. And now, if Dolorix goes into a trance and pictures a human, DNA will be produced out of her ears, and this DNA, when put into a human egg, will produce Dolores again.
Yeah, and you'll have 5 different types of Dolores, right?
Yes.
Yeah, and this analogy, DNA, ANA, BNA, CNA, and ANA are kind of like the source code of the multiquine. The Dolori, Dolores, Dolorix, Dolorium, all of them, they are the compilers, right? The compilers of the program that take in code and produce output, right?
Yes.
And the output is the source code, the ANA, BNA, etc., right?
Yep.
Meditation is the process of compiling the code and outputting stuff, right?
Yes.
Yes.
And the image that they choose to put in their head during the meditation is the input to the multiquine.
Yeah.
Ah.
Yeah, and so that is the story of the Dolori of Planet Xanet.
That's so cool. All right, now for the rest of the episode, sadly, I must dip out. But
Boo. No, just
yeah,
kidding.
what a weird phrase. I'm sorry I'm using that phrase. I should apologize to dip out. I don't know. Well,
Well, that's a real phrase.
it is a weird. So my nephew says that whenever he
Oh, no,
leaves.
but I mean, I've totally heard that before. It's totally normal.
But dip, I think of like you're dipping into. How do you dip out?
When I dip, you dip, I dip, we dip.
Okay, can you play the sound clip from that? Okay, Gabe's dipping and keep saying that later. I'm not going to go actually dip. That's disgusting. Okay, anyways.
Oh, like with tobacco.
Yeah, exactly. It's a weird phrase. It makes me feel weird saying that. Anyways, I'll save the rest of the episode for you too. I'm sure you guys will do a great job. Please follow us on all the socials. And yeah, we will do some great episodes that are coming soon. So,
Yeah, SciPod Sophia.
TechPod Gabe.
And I'm Camp Pod Millie, and that's Camp with a K.
Okay, and we'll see you guys in the next episode.
Awesome. Now we're going to talk about recursive definitions in mathematics. So the first example we're going to give, which we've talked about this on multiple episodes, is Peano arithmetic, which was created by Giuseppe Peano, who was born in 1858 and died in 32. The definition that it's addition for specifically integers, right?
Yes.
And you know what an integer is, right?
Integers are if I remember correctly, that's when you put things in brackets, right?
Actually, no, that's I can't remember what that's called right now. But an integer is just 0, 1, 2. Oh, actually, not integers; these are natural numbers. But integer is a whole number, like -3 or 57. And a natural number, which is what piano arithmetic is for, is 0, 1, 2, 3, all the way to infinity. So -2 is not a natural number, right?
Yeah.
But 72 is.
Yes.
And 0 is, but -1 isn't, etc.
Yes.
So the way that addition is defined within piano arithmetic is using a function called the successor function, where the successor of 3 is 4, the successor of 5 is...
Sorry, the successor of 5 is 6, right?
Yep, 6. Successor of 100 is...
101.
So the way that addition is defined is using the successor function. And the definition is A plus the successor of B is equal to the successor of A plus B. And A plus 0 equals A. Those are the two rules for piano addition. So let's give an example. So let's do 3 plus 4, right?
Yeah.
3 plus 4 is 3 plus successor of what?
Successor of 3.
Yeah, and so this 3 plus successor of 3, given this definition, is a successor of 3 plus 3, right?
Yes.
So now we're going to look at 3 plus 3. 3 plus 3 is equal to 3 plus the successor of 2, right?
Yes.
Which means that 3 plus successor of 2 is equal to the successor of 3 plus 2.
Yes.
Then so now we have two successor functions that we're dealing with. Then the third thing is 3 plus 2 is equal to 3 plus successor of 1, right?
Yeah.
Which means that it's the successor of 3 plus 1. And then the next one is 3 plus successor of 0 is successor of 3 plus 0. And 3 plus 0 is just...
3 plus 0 is 0. No, sorry, 3. Sorry, I'm thinking multiplication. I'm all over the place.
Oh, yeah, you've been getting bad sleep.
Yeah, I've been getting bad sleep, so I'm half awake, everybody, so I am not up for math today.
But we'll plow through. So we have the successor of the successor of the successor of the successor of 3 is our answer, right?
Yes.
So it's the successor of 3,
4.
the successor of that,
5.
the successor of that,
6.
and then the successor of that,
7.
7. So 3 plus 4 equals 7. And that's how addition is done in piano arithmetic. Does that make sense?
Yes.
And you might be wondering why this is defined this way. It's because Peano was trying to figure out a way to define the natural numbers formally so that they could be manipulated on paper using simple rules. But a theorem called Gödel incompleteness theorem showed that there are statements that are true within Peano arithmetic that you can't prove using Peano arithmetic, which is kind of strange.
Yeah.
And actually, that goes for any system. No matter what system you have for math, no matter how complicated it is, you will always find at least one thing in that system that you can't prove within that system that happens to be true. It's kind of fascinating. And the reason why is because any formal system is either inconsistent, meaning it's basically useless, like we did with naive set theory earlier. That's inconsistent theory, or incomplete, and those are the only ones that are useful.
No, really.
So weird.
Yeah, that is weird.
It's one of the most insane results in mathematics. And factorials are defined the same way. Do you know what a factorial is?
Not entirely.
Well, so the factorial of 5 is 1 times 2 times 3 times 4 times 5.
Okay.
Factorial of 0 has to be 1. Because the reason why is because since the factorial of 1 is equal to 1 times the factorial of 0, right?
Yes.
And the factorial of 1 has to be 1, so that means that factorial of 0 has to be 1. So n factorial is defined as n times n minus 1 factorial. So that's just another thing. Also, the gamma function is related to it. The gamma function of n is equal to n minus 1 factorial. But the gamma function is defined for all numbers, not just integers, right?
Yeah.
And so, it's defined as the gamma function of n plus 1 is equal to n times gamma n. Another example is phi, the golden ratio. You've heard of this before, right?
Yeah, but don't ask me for any information about it.
Well, what it is, put simply, is that let's say you have like a meter stick, right?
Yeah.
And let's say you want to take a piece of it such that the ratio between the entire meter stick and that piece is the same as the ratio between that piece and the smaller piece left over. So, and what that turns into is the definition phi is equal to 1 plus 1 divided by phi. And so if you plug that definition into phi, you get 1 plus 1 over phi. And if you plug that in, you just get that ad infinitum, which means that phi is equal to 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 all the way to infinity. And yeah, self-reference in this form is useful in so many contexts, right? It's just it's become a fact of mathematics at this point.
Yes.
Do you want to ask any questions? Do you have any?
At the moment, not so much. It's just I'm wrapping my head around it, and I'm getting that. So self-reference, it's because of the fact that a lot of it is to prove theory and stuff like that.
Oh yeah, but prove things. The big one is defining things. Because sometimes it's easier to define something in terms of itself than it is in terms of other things.
Well, yeah, you can't define something if you're not aware of what it is.
Oh, yeah, but what I mean is like phi is equal to 1 plus 1 over phi. Yeah. It's like, well, how do we calculate that, you know? It's like, well, you just kind of plug it into itself forever. It's like, what would you now? And it turns out that if you plug in this last phi with any number, it'll just converge to phi if you just keep adding 1 and then taking 1 divided by that forever, you'll get phi.
Yeah.
And yeah, phi just happens to be like a nice little ratio. It's overused though. The golden spiral is not in every Renaissance painting like everyone says.
No, it is not.
It's fun though to put spirals on things. It's still pretty. I like it. Millie, have you heard of the Cantor set?
The Cantor set? No, actually I have not.
So this is the way it's made. Let's say we draw a line, right?
Yes.
And let's say we erase the middle third of that line. Hmm? You have 2 lines left over, right?
Yeah.
Now let's erase the middle third of those. You have 4 lines left over, right?
Yeah.
If you keep doing that forever, you'll get what's called the Cantor set. And what's funny is that the Cantor set has a length 0, and it actually has a dimension between 0 and 1.
Interesting.
But Millie, did you catch how the Cantor set is self-referential?
No, actually I did not.
Well, think about this. If you take the Cantor set, right?
Yeah.
And you squeeze it into the size of one of the original lines, it'll match, right?
Yeah.
So that's what a self-referential fractal is. You can find the fractal inside the fractal.
Ah.
And we also have the Sierpinski triangle, and you've encountered that, right?
Not too sure if I have actually.
It's like the Triforce from Zelda.
I do.
Imagine all the triangles were made out of Triforces, etc. So basically, what it is you first take a big triangle.
And you make it out of smaller triangles? Yeah,
you cut out the triangle in the middle that turns into 3 smaller triangles that are equal, right?
Yeah.
And you cut out the middle of those 3, and you keep doing that forever. And you get a fractal with dimension between 1 and 2. And the Sierpinski triangle, did you catch how that's self-referential?
because you're just creating triangles nonstop. You're just basically duplicating the original shape.
Yeah, if you take and you can actually define the Sierpinski triangle in terms of itself, right? You could say the Sierpinski triangle is the thing that if you copy it here, like to the bottom left, top, and bottom right, you'll get the Sierpinski triangle.
Yeah.
And then we got the Mandelbrot set. And Millie, I'm going to look up a picture of the Mandelbrot set for you. You've seen this, right?
I have, actually, yes.
And what's funny is that the Mandelbrot set is self-referential as well. It turns out that there's a lot of little circles within the Mandelbrot set. And if you take the ratio of successive circles and you go to the point that is defined by them, you'll find another Mandelbrot set. And it was created by the complete curmudgeon Benoit Mandelbrot, who believes that he has who believed that he had a monopoly on everything fractal. But that's an episode for another time. That'd be a fun episode to do, jerk mathematicians.
Yeah, but we'd be here like all day, I think.
Oh yeah, we'd be here for a while. Like, honestly, not as many mathematicians as you think are like outwardly jerky, but quite a few are.
Yeah, I'm also physicists don't count as mathematics people, do they?
Well, no, not math per se, but they use a ton of math, obviously.
Okay, so yeah, because I was gonna say I'm more aware of physicists being.
Yeah, I think that'd be a really fun episode, actually.
Yeah, that sounds fun. Actually, I'd be interested in it. Oh, I do know that John Nash had some very, very, very backwards views regarding women.
Yeah, he's a complex character, to say the least, right?
Well, yeah.
And John Nash, for anyone not acquainted, was he was a game theorist, differential geometer, and he made a lot of contributions to partial differential equations. And he studied a lot of complex systems, but he was very schizophrenic, treated, and the schizophrenia was treated in like the worst way possible in the late 50s, early 60s. And I don't recommend anyone watch the movie, A Beautiful Mind. It completely mischaracterizes him and his research.
They don't even show him getting arrested once for soliciting sex from a cop.
That happened multiple times, right?
Yeah, it happened multiple times in John Nash's life. Like he was also closeted and secretly gay. But yeah, he used to go and try to pick up men all the time, and he had the worst luck ever because he would always just run into cops.
Oh, yeah.
And this is back when they did like those ridiculous gay stings.
Oh, yeah, thank God things have changed.
Careful analysis of self-reference has led to many fruitful results in mathematics. Over and over, we see new ways in which self-reference can be used. Nebulous and mind-bending as a concept though it may be, self-reference has always been around. Creative ways to reference the self, it seems, will always be around. Limits of mathematics, ways of dealing with information, and the structure of mathematics itself have been proven to be dealt with often better with self-reference. Understanding consciousness itself may even be only tractable using the magic of self-reference. Self-reference is here to stay. In the future, ask yourself what asking yourself things means. Oh, by the way, is this conclusion self-referential? Nobody knows.
I'm Sophia, and this has been Breaking Math. With me and Gabriel, who's not on anymore, we had Millie, who is part of Nerd Forensics. Millie?
And you can find me anytime at Twitter at CampPodMillie, and that's camp with a K. And otherwise, you can find me at nerdforensics@gmail.com. And as always, you can find me on Facebook at facebook.com/nerdforensics.
And really quick, do you want to just plug your show, what it is?
So Nerd Forensics, we are an amorphous omnibus series that just covers everything in pop culture. We're going to have episodes ranging from conspiracy theories to cryptids to why Nickelodeon in the 90s can't be reproduced.
And what was what would you say was a couple of your favorite episodes you've done that I've helped you with? Well, I produce this show, but
favorite episodes that I've done, the anime one that I recorded with Jacob was really great.
Oh, I really liked that one.
Otherwise, I really, 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 really enjoyed the one we did about magicians.
Oh, that one was great too. Yeah, so if you like a pop culture at all, or just like cool stories, honestly, this podcast, it's a really cool podcast. Check it out on Nerd Forensics. You can find it wherever you find podcasts. And just a little warning, it is an explicit podcast. There's some bleeping, but, it definitely contains much more risque content than this show, right?
Yes, it does. I have much less of a filter, but I don't consider myself an educator. Think of me as the guy you don't want to sit next to on the bus.
So...
Get everything for your next project today at Menards and save big money. Keep your walls and trim protected while you paint with Scotch Blue Painter's Tape. It's designed for use on multiple surfaces and can be removed easily without leaving residue behind. Save big on Scotch Blue Painter's Tape from Menards. Also, view our weekly flyer on menards.com and check out all of our great deals happening this week.
Save big